Lesson 5, the inner planets, investigating Mercury, Venus, Earth, and Mars. Let's look at key terms before we begin. Planet, a celestial body moving in an elliptical orbit around a star. Moon, the natural satellite of the Earth. Space probe, a spacecraft carrying instruments intended for use in exploration of the physical properties of outer space or celestial bodies other than Earth. I didn't include a picture of planet and moon because I think you guys kind of know what those would look like. Planets, though, are just not in our solar system. It can be any star. So we know that the galaxy and the universe is just filled with tons of stars. So there could be planets that are revolving around other stars besides just the sun. But we're just going to study the planets that are within our solar system. The moon is a natural satellite of the Earth. A lot of times we consider other planets having moons, but we'd also like to call those satellites. Natural satellites are different than the satellites that we put in space that are man-made. And then the last word, space probe, the picture below shows you Curiosity, which is a space probe right now that's on the surface of Mars, taking some really awesome pictures that you should check out. Our last key term is astronomical unit, and I will use the phrase AU, the abbreviation. Most of the time you'll see it says AU, and the AU stands for astronomical unit. An AU is the unit of measurement equal to 149.6 million kilometers. It's the mean distance from the center of the Earth to the center of the Sun. So the picture on the left helps you kind of picture what that distance would be. We know that the orbit is actually elliptical, which means it doesn't make a perfect circle like this picture. So what the scientists have done was they've taken all the distances the Earth is from the Sun. Like we know in the winter time, we're actually a further distance away from the Sun than in summer. So they would add up all these distances and then divide it by the number of days there are in the year. And that average distance is the AU. That would be 1 AU. So the picture on the right shows you the average AU for each of the inner planets. It's the average because we know that planets are sometimes a little bit closer to the Sun than other times during their orbit or their revolution. So if you look, the two planets closer to the Sun, Mercury and Venus, have an AU less than 1. If Earth is the standard 1, anything closer to the Sun than the Earth is obviously going to have an AU of less than 1. Whereas anything further away from the Sun than Earth is will have an AU greater than 1. So Mars, you can see, has a 1.52 AU. You can also compare each to kind of get an idea of how much space is in between planets. For example, Mars and Earth is 0.52 AUs. That's about a half of an AU from Earth to Mars. Whereas if you look at Venus to Earth, that's only 0.28. So it's a lot closer between Venus and Earth than it is Earth and Mars. So this kind of just helps you be able to kind of figure that out. And really, if you look at Mercury, Mercury to Earth is 0.61 AU. So it's only a little bit further than Mars. So you can tell, and they kind of show in the picture that Mars is a little bit further separated than the three planets, three inner planets. So we use the AU to help us compare the distance from the Sun. Link. What technology has enabled us to find out more about Mercury, Venus, Earth, and Mars? So think about that for a little bit. On the technology that has been invented, how we have learned about these planets compared to in the past, how they learned about these planets. Did you ever want something that was out of your reach? What steps did you take to get it? Did you invent some way to reach the item, a long pole, with a hook perhaps? Reaching for objects in outer space is similar to that. Scientists really want to know about the celestial bodies in space, but until recently they have been out of reach. So people have invented ways to get them. You have already read about some of the inventions, such as space shuttles and stations. In this lesson, you will learn about the 4 inner planets by reading more information gathered from inventions created to make the planets reachable. So I want you to take a little time and answer these questions in your notebook before we move on. Number 1, if you were to build a device that had the ability to reach the planets for gathering information, what would you build? Number 2, how would your device get around? Number 3, what types of technology would you include on your device to observe the planet? How would this information get back to you? Number 4, in your notebook, draw this device and label its parts. So you can go and hit pause right now and answer those 3 questions in your notebook. And then after you finish answering those 3 questions, draw a sketch of what this device looks like that you're picturing in your head. All right, now you're going to research the inner planets. You will use this graphic organizer to take notes. So I've handed you this information chart already, so it should be in your notebook. You've got 2 sides, one for the inner planets, and you're going to do the same activity for the next lesson, lesson 6, when we do the outer planets. So the key things you need to look for are the distance to the sun in kilometers, distance to the sun in AU, the diameter, the period of rotation. We need to remember rotation means days, so it's how long is a day. Revolution in Earth years, the number of moons, or we like to say satellites, and then unique characteristics and features. The videos you're about to watch are going to have lots of information, so any additional notes that you want to take can go in this last column. And if you run out of room, you can always just keep writing in your notebook the unique characteristics and features that you thought were interesting. So for your activity, you're going to watch the other videos that are on the page. Go back into Blackboard and watch the videos for each planet and record the information. The AU may not be given in the video. If you go back to the beginning of this lesson, of the video you're listening to right now, you could find the AU on the slide that defines astronomical unit. Next week, you will write a short report on one of the inner planets. You will use your graphic organizer to write your report, so you want to make sure you get these notes today. Remember that rotation is the reason for day and night, and revolution is the reasons for years. So when you hear them talking about days and nights, that has to do with rotation, or how long a day is. And when they talk about how long years are, that has to do with the revolution. So go ahead. We're going to finish this video, so stay with me for a little bit longer before you go to the other videos. In summary, I want you to answer these in your notebook. Number 1, what is the difference between a planet and moon? Number 2, what is a space probe? How are they useful? And there's 3 parts to number 3. What is an astronomical unit? How do AU compare to kilometers? And C is, why do scientists use AU instead of kilometers? Just go ahead and get these questions answered. You can, after you have listened to this, you are ready to go to back to the videos on the Blackboard site. So go on back now and start with Mercury and just work your way down into Mars. And hopefully you'll have enough time to listen to all the videos so you can get all your notes taken before you leave computer lab. Have fun learning about the inner planets.